15 kW. If you go with a replacement of the boiler, it goes to 40. So there's no other way of freeing that energy unless you use a transmission system. The energy model allows for the analysis of the transmission line owned by a distributing company or by the mill. That applies to Goiás and Mato Grosso because there is a distributor network that also serves the mills. I don't see any problem in that. What we lack is planning. So how will I bring from each geographical area the mill is located, having a schedule of entry and planning and the cost and identifying with the computer models that PSR has developed for the two states what is the best location for this collection agent. We have to have the chicken foot, a central distributing center that branches out to other basic network distribution center. There's no other way of doing that. There are at least 8 or 10 mills that allow for some sharing. Even the mills that need retrofit, after you jump from a 10, 15 megawatts export to 70, there's a different connection. It's a different whole line. So there are cases, and the lowest cost is for one plant or one mill to connect to the other and then go to access the network. It's where all the mills in São Paulo are connected. So there's a question. Qual é a explicação para aumento do consumo de energia elétrica no Brasil em dezembro, janeiro e fevereiro? Ar-condicionado? Quais são as horas de pico e fora de pico? Qual é o diferencial de preço nas horas de pico e fora de pico? Well, about the increase in the load, well, it's summertime, so air conditioning is the main driver of the seasonality of the load in Brazil. Peak hours in Brazil go from 7 or 8 p.m. until 11 p.m. where you have lighting needs. People come back home, turn on the TV, use their appliances, and and so on. Well, in terms of peak and off-peak loads, there's something interesting because the load is modulated by the power plants. The thermal power plants, when called to operate, they operate in the base. So there is an excess capacity of the hydroelectric plants that modulates the load easily. So in terms of energy costs, it won't make any difference to whether you generate it at the end or off the end. So there is a complicating factor because the tariff to large consumers at the end has to be 70% higher than those that are not located at, which brings distortions to the system. And we are working on that on PSR because that does not reflect the cost of energy generation. A question for Silvestrin from Agoni. In a scenario of uncertain auctions with a decrease in free consumers, less consumption of energy and preference for thermoelectric plants, What motivates the mills to change their boilers from 21 bar to 60 and 90? What everybody wants is a clean energy. That's what everybody wants. That's not what is available for everyone. So we're wasting this capacity of producing only hydroelectric matrix, and we're going towards a double matrix. And both the free market and the industries that want to purchase a more sustainable energy, that they have a green proposal, as many companies are doing, is to purchase bioelectricity because it can be sold both in the regulated market as well as in the free market or unregulated market. So in the wind energy, that does not apply. So the reason has to be what to do with the biomass that I have available. If the mill cannot burn that on open air, you have to either try to export this biomass somehow, or making souvenirs, or trying to use that to produce energy. And there is a synergy logic around that then doesn't all rely on the existence of auctions. So if you need further details, I can give you, but that's an opportunity that exists. We have three more questions.
Tem uma pergunta que foi dirigida a todos, mas eu vou pedir para o professor Nivalde, foi ele até que abordou esse assunto na apresentação.
Well, the person doesn't identify his name, but I think it's a relevant question. In the opinion of each speaker, in Nivalde here, what would be the argument that would allow for bagasse to win in the fight for second generation?
What is the winning argument in the dispute for the bagasse for bioelectricity that you burn in the boiler, or for a second generation ethanol? It seems to me that scale aspects, smaller plants, retrofit will have some difficulties to join the second generation technology. And apart from this, you have a more diversified portfolio, because adopting second generation technology, you'll be exposed to commodity oscillations, ethanol oscillations, while having a mix of bagasse focused on biomass, you are able to sign 15-year contracts with first knowing the cash flow and using this contract as a receivable to get financing for turnover or starting point. So the good business is when you have a diversified portfolio that you reduce your risk. I would like to complement, which is the timeline. We'll have only projects for cellulosic ethanol, depending on the economics, in 10 years from now, in terms of volume and industrial scale. What you are going to do with this biomass? You are going to make it values right now? That's the question we should ask. We have such biomass that we are not going to compete for the existing biomass. Use this biomass, make it electricity, and you'll have cash to finance your growth and expansion. We have questions for Granville. He asks some conversion. Brazil produces 1 gallon of fossil fuels for 9 gallons of ethanol, and he's asking about some conversions. Well, there are some rules. 1 ton of corn you get in an efficient boiler 85 kilowatts hour. If you have 1 million tons of sugarcane, you produce 10 average megawatts a year. What this means, 10 megawatts, is the capacity to produce 10 megawatts along 8,760 hours of the years, which represent 87,000 megawatts hour. So basically, this is it. But now you have to calculate for 1 ton of sugarcane. 1 ton of sugarcane represents 90 liters of alcohol. And based on this, you can make your calculation. Once you need 1 gallon of fossil fuel to produce 9 gallons of alcohol. So I need a piece of paper to make these calculations. Well, he can ask you personally afterwards, but it depends on the technology you're using. You mentioned 85 kilowatts hour, but we can reach up to 200 kilowatts hour, depending on the technology. The last question before closing, and I'll direct it to Granville, says about fuel cells. What is the perspectives of fuel cells having ethanol as feedstock? Well, what I know is that fuel cell is very. So before giving the last announcements, I would like to thank the presence of Granville, Silvestrin, and Professor Nivalde. We had a very interesting discussion here. I would like to make 3 comments about the issues which were highlighted but were not stressed enough. Professor Nivalde mentioned the auctions that we need to adjust the method they are being held, and it's favoring thermoelectric plants. What I feel is that we need